Very sorry. Our recording in progress, as you may have heard, we will be recording this session. We have all our panelists in person for this one, but we do have audience online with us. So for those online, please put your questions into the Q&A box. You can do that during this presentation and we will get to you in the order that we see you come in. Please tell us who you are and who you're working for. For those in the room, you can just raise your hand during the Q&A, which will proceed as soon as all of our lovely panelists have finished their presentations, and we'll bring you a mic. So we'll go back and forth between all of you here in the room with us in Chicago and those online. And for that, I'm going to hand it over to our panelists to introduce themselves and start their presentation. Thank you.
Okay, good morning. My name is Lauren Fry, and I'm from NOAA Great Lakes Environmental Research Laboratory. And I'm going to kick things off by providing a brief overview of the Great Lakes and how regional climate impacts the Great Lakes water levels. But before I start off, I wanted to just show you this image, this map of coastal watersheds in the Great Lakes, which I think really hits home the importance of the Great Lakes as a coastal resource. So the Great Lakes are home to the third largest population of coastal watersheds in the United States. The second thing to point out on this image is that we're missing half of the basin. The Canadian border essentially bisects the basin, and that gives me a good opportunity to talk about the importance of binational management of the waters of the Great Lakes, which is done by the International Joint Commission, and that's with support from federal agencies on both sides of the border. And those federal agencies work closely together to collaborate and coordinate data and models. And for that binational management to be effective, we really need to understand past changes in the Great Lakes hydrology and future changes in the Great Lakes hydrology. So here I'm showing the long-term record of monthly mean lake-wide average water levels dating back to 1918. And this is for Lake Michigan Huron. So I call Lake Michigan Huron one lake because Lake Michigan and Lake Huron are connected at the straits, so they rise and fall together as one lake. So, you see periods of the wiggles, that's the seasonal cycle, plus interannual variability, high and low water levels. Both of those patterns, the seasonal changes and the interannual variability, are primarily driven by the combination of precipitation over the lake, runoff into the lake, and evaporation from the lake. I really like this MODIS image from a storm in 2014. This is the same storm that produced that earlier lake effect snowstorm in Buffalo, similar to what we saw this past November. And it really shows the importance of evaporation in the winter on the lakes. So in the winter, the evaporation is driven by the difference between the lake surface water temperature and the atmospheric temperature. So you have this strong gradient between relatively warm surface waters and colder blasts of air that are coming into the basin. Some of that evaporated water comes back to the land surface as lake effect snow, and some of it leaves the basin. And then in the spring, we see that our seasonal rise, which is really driven by the melting of snow plus more liquid precipitation falling into the lakes. So all those three things, precipitation, runoff, and evaporation, are driving water levels, and they're all driven by the regional climate. So what do these water level changes mean for people who live along the coasts in the Great Lakes? So I'm showing here access to the same recreational dock during the low water period that we had recently in 2008 and a recent high water level period in 2019. This is still water conditions. It may not look like a lot if you're coming from ocean coasts, but here in the Great Lakes, we're not necessarily designing with that kind of change in mind, especially on an interannual, multi-year basis. And then when we add in the conditions that can be caused by storm, like surge and waves, we can start to see important flood events and coastal erosion that can have really significant impacts around our coasts. So again, the water level changes that we see are primarily driven by precipitation, runoff, and evaporation. All of those three things are driven by regional climate, and the future of water levels will really depend on how those three things balance out, how climate impacts each one of those things. I want to point out that on this period of record that we have for Lake Michigan Huron dating back over 100 years, we really don't see a clear trend of increasing or decreasing levels. What we really see is periods of high and low water levels with changing variability. So what kind of climate are we expecting in the future? These maps were produced by our partners at NOAA Great Lakes Integrated Science and Assessment Team, and they're showing that we'll be seeing by mid-century warmer and wetter conditions, but they note that those wetter conditions are really expected to be variable by location and by season. So for example, much of the basin will be seeing drier conditions in the summer time. So when we combine the uncertainties that are around climate projections, along with the uncertainties around how that climate will propagate into the changes in the balance between precipitation, runoff, and evaporation, the take-home message is that resilience and adaptive management really needs to consider both high and low water levels going forward. So bringing this back to water management in the basin, a couple of challenges that we have with respect to the science behind water management is that we're dealing with huge lake surface areas where we have important processes like overlake precipitation and overlake evaporation, but we have very little in the way of surface observations across these expanses of surface water. The second is that binational border that I mentioned earlier that really requires coordination of data across our two countries. So I have a couple of presentations this week that are talking about advancements in modeling and data to support that binational water management, specifically with respect to management of outflows from Lake Superior via the St. Mary's River and outflows from Lake Ontario via the St. Lawrence River. So now I'm going to hand it over to Alexander to talk about future changes of water levels.
Thank you, Lauren. As you mentioned, I'm Alexander Vandewey from the University of Michigan. And I'll be talking a little bit more about water levels and get into how we project water levels for the future. But before getting into too much depth, I'd like to call attention to the image that I've highlighted on the right. This is the cover of AGU's EOS magazine from a few years ago. And in the background, for those of you in person, you'll recognize the skyline of Chicago, where we are today. While in the foreground, there's a wave from Lake Michigan crashing over Lakeshore Drive. This highlights the sorts of impacts of coastal flooding, what Lauren mentioned, and the different impacts that we'll hear about in a few moments, and underscores the importance of understanding water levels and what drives changes in water levels. I'd like to take another look at the historical record shown here for Lake Superior, Michigan, and Huron, treated as one, and Lake Erie for about the past 150 years. There are two recent water level periods that I'd like to highlight. The first extends from 1998 to 2013. This period was characterized by consistently low water levels across the lakes, even historically low water levels on Michigan Huron. And these low water levels drove concern over chronic water loss from the lakes and contributed to a narrative that climate change might be causing ever decreasing water levels. That all changed in 2014, when over the next 5 years, water levels rose rapidly across the lakes, culminating in record highs between 2017 and 2020. And this dramatic change really upended postulations about chronic water level decline in the Great Lakes and underscored the need for more robust understanding of water level change and what drives those changes. As Lauren mentioned, there are kind of three key factors we think about for what do drive water level change, two of which I'll showcase here on the y-axis as water level equivalent above or below their long-term average. And those are lake precipitation and lake evaporation. Shown in the third panel is their cumulative effect on water level. So if we look at the two periods that I called out on the last graph, the first from 1998 to 2013, precipitation is somewhat variable, but relatively low, while evaporation is consistently quite high. And the net effect of that is a loss of water from the lakes that resulted in the low water levels we saw in that period. Now that's in sharp contrast to the patterns that we see from 2014 to 2020. This period is characterized by very high precipitation, even record high precipitation, coupled with below average evaporation. And that cumulative effect is an accumulation of water in the lakes, and that leads to the rapid rise that we saw across that time period. Understanding these drivers of lake level change also informs how we model lake levels into the future. So by sampling plausible values of this precipitation, evaporation, and of runoff, we can create a sequence of plausible future water levels. One possible sequence might be shown here for Lake Michigan Huron, and this is repeated hundreds, thousands of times. And that gives a distribution of what water level range might look like in the future. So if we examine some average trends, here for two plausible climate scenarios that are both blended representations of statistical and mechanistic change, we see that although there's some variability across the lakes and across the months of the year, the long-term average water level in this study is projected to have slight to moderate increases, something on the order of a couple inches up to just under a foot. And this is in agreement with two other recent studies out of Michigan Tech and Environment and Climate Change Canada. Now, this study is only one of a suite of modeling efforts to project change in Great Lakes water levels, and there's significant variability and uncertainty even within our results. So this plot shows all of the different sequences of plausible future water levels for what we're calling climate scenario 1, which you'll recall has the greatest projected increase in average water levels. But even with that being the greatest projected increase, there's still significant variability. Some of these sequences into the future even show that long-term average water levels might experience slight decreases. Some show only very small increases, and some show larger ones. This large band of possible results really highlights the uncertainty and complexity that comes with modeling the system. Perhaps even more importantly, by examining any single plausible future sequence of water levels, we see that there are periods of both high water levels and low water levels continuing into the future, as we've seen in the past, which Lauren pointed out. We conclude that water level variability in the future will be at least as great as it has been in the past. And this underscores the need for management and coastal planning decisions that support resilience to water level variability. I'll be around for the rest of the week, give a presentation, and I'm happy to take any questions throughout that time. And with that, I'll turn it over to Yihong.
Okay, thanks, Alex. So, following the discussion of water level changes with Alex and Lauren, this talk we will focus on impacts of flooding on Great Lakes coastal communities. So I would like to start with this aerial photo taken by Fox 17 News over a coastal area of the West Lake Michigan. And as we can see in this photo, and also from other news reports, there are many flooding have occurred along the coast of the Great Lakes. And also people living in the coast of the Great Lakes are susceptible to flood hazard, but the flooding could disproportionate impact different groups of populations. So in this study, we aim to analyze these unequal risks. So first, as a background information, in fact, the flood and social vulnerability analysis have been performed widely over the East Coast, West Coast, and Southeast Coast of the United States, but very few studies have focused on the Great Lakes region. So this study aims to fill in this gap. And also, as presented by Lauren and Alex, there is a trend towards increased lake level variability and uncertainty of the Great Lakes, and also together with the more intense storms, there might be more flood events along the coast of the Great Lakes. So in this context, we have coupled a real-time forecast modeling system, which could simulate the flood hazards along the coast of the Great Lakes. and people are at risk when they are exposed and also vulnerable. So the objective of this study is to quantitatively analyze the flood extents at the census tract level, and also to quantitatively analyze the unequal flood risks for different groups of populations. So these slides briefly describe our modeling system. So we can see that our real-time flood model use unstructured grid model, which have a resolution about 200 meters along the coast. And coupled with a very high resolution of LiDAR data, we can identify the low-lying areas along the coast of the Great Lakes and to see where are flooded. So these are two pictures that shows the verification of our model. We can see we taken this aerial photo as an example. We can see that the floods occurred in Montague in April 2020, and our model simulations accurately reproduce the flood events. And moreover, we can have the flood extents at the community level according to the simulations. So using the simulated flood extent at the census tract level, we can quantitatively analyze the distribution of different groups of population living in these coastal areas. So this study, we focus on 4 categories of the socially vulnerable people, which are based on age, race, education level, and income. So comparing people living inside and outside the flood-prone areas, we could analyze whether socially vulnerable people are more likely to live in the flooded areas. So these are some key findings of this research. First, we want to know where are flooded in the last 3 years. So taking Lake Michigan as an example, we can see that the flood extent, this simulation of the flood extent at census tract level. So in general, we can see that the Green Bay area in Wisconsin and the Chicago area where we are now are most susceptible to flood hazards, that up to 30% of certain census tract could flood it during the last 3 years. And also other regions like Lake County and also the Benton Harbor in Michigan have up to 10 to 20% of census tract are flooded. And based on this information, we could calculate the distribution of the socially vulnerable population living outside and inside the flooded area. And according to this figure, we can see that the socially vulnerable people are more likely to live in flood-prone areas, especially for the minority and also for low-income populations. So we can conclude that those populations are facing a disproportionate high flooding risks. So in this presentation, we take Lake Michigan as an example. So we are currently running analysis for the coast areas of the entire Great Lakes. And this week, I have another presentation tomorrow afternoon. So if you have any questions and comments, please feel free to contact me or have a chat. Thanks. So I will pass the voice to Riley.
Hello, my name is Riley Balikian. I work at the Illinois State Geologic Survey in geophysics and hydrogeology. And my research here at AGU is focused on using satellite data to monitor coastal erosion along the Great Lakes. And because I work here in Illinois, it's along the Illinois coast. So as Alexander and Lauren showed, especially, the Great Lakes have varied a lot over the last century. What I'm going to focus on is about the last decade or so, which is that second period that Alexander was looking at approximately. The reason looking at the last decade is in part because it was one of the most dynamic periods in the lake level record. There were 8 years in which the lake levels rose about 6 feet. And then immediately after that, in the past 3 years, it's fallen about 3 feet. So that's a historically rapid change in both directions. And then that last decade or so happened to coincide with the rise of several modern satellite imaging instruments. So for example, the 2 data sets that I use in this research, and that you can see the imagery and the radar data here, One of them began its current operation resolution in 2016, and the other began operation in 2014. So these are relatively new instruments and methods. Now, satellite data is really useful because you get high resolution data and you can get over a large scale. So you can see the image on the right there is covering about the southern half of Lake Michigan, southern third. And it allows us to really analyze at a small scale, which is on the left, some of the satellite data we see. So why do we care about coastal erosion on the Great Lakes and Lake Michigan specifically? So here, coastal erosion here is not a new phenomenon. It's been happening for as long as there have been geology and people living in the Great Lakes. It's changed dramatically over the geologic and human timescales. What is new is the large population centers along the coast of the Great Lakes and Lake Michigan. So where we are is a great example. So here in Illinois, and that's why we're here in Chicago, is because it's a great population center. But Illinois represents about 1%, a little under 1% of the Great Lakes coastline. But about 31% of the people that live in the counties that directly border the Great Lakes coast live in the 2 counties in Illinois that border the Great Lakes. It's even a smaller percentage of the basin. So here in Chicago, the Chicago area in Illinois coast, you can see that erosion is not just an environmental or geologic issue. It's an economic issue, it's a social issue, and it can even be a political issue. So there are many different kinds of satellite data that we can use to look at the coast. What I'm going to be using are 2 types, what I use in my research. So satellite imagery, which is also called optical imagery. A lot of people are more familiar with this. The one difference with mine, it's a little bit higher resolution than what you can get publicly. And then on the right, which is a public data set, is synthetic aperture radar, or called SAR for short. And this is a relatively new application for that type of data. Both of them have their strengths and weaknesses, which is why we want to use them in tandem. So I'm going to use the image on the left, the satellite imagery, to just point out a specific site, location, and give you an example of why this could be important. So this is a satellite imagery taken about 6 years ago. The chart on the right represents approximately that second period that Alexander pointed out, about the past 10 years or so, from 2010. And that dot there, that blue dot, represents where this image was taken along that timeline. Now I'm going to also show you here in that white line, you might not have seen it come up very clearly, so let me show you that again, is the shoreline at this particular time. So we'll fast forward 6 years to an image that was taken a few weeks ago, and you can see the shoreline has changed. So that's the new dot on the right there on the chart. You can see the old dot. And at the most dramatic location at this particular site, there's over 100 feet, or about 100 feet of erosion just in the past, in the 6 years between those 2 images. Now you can see there's variability along the coast, and we're just pointing out the highest point here. But this is an example of how you can get some large changes in some small periods of time when there's a dynamic lake level and other processes happening. You'll also see along the coastline here that it's a lot sandier in this image than it was in the past. So we've lost a lot of the environmental resources along the coast here with this particular period. In fact, there's some pretty unique wetlands in this particular site, which is only about 50 miles up the coast this way in Illinois. I want to point out here that there are a lot of there's a lot of different variability in the coastline, both along the Great Lakes in general, but also in Lake Michigan. So the methods that we use here, that image you saw is in the Zion Beach Ridge Plain up in the northern end there, but there's also bluffs that rise about 100 feet above the lake level in that lake border moraine bluff coast. And then we also have a great urban and industrial complex spreading all the way down till we get to the national park at the Indiana Dunes National Park in Indiana. So there's a great variability just in Illinois. And so as we're learning how to do this coastal erosion monitoring with high resolution satellite data, there's lots of ways that we can practice and get some good idea of how different types of coasts might respond to different types of inputs and drivers. Yeah, I'm going to be presenting a poster as well on Thursday. If you want to come see that, I'll present some more of the results and methods that are used in this. But what I want to say is that I'm excited about the future of satellite monitoring for this type of application. There's a lot of changes in the future and a lot of methods that are still being figured out and tried out. So in fact, in the next year or so, NASA, the US and India will be launching a joint mission called NISAR that will greatly increase the resolution of the SAR data on the right and the applications that it can be used for. And I'm excited to see that come online and apply that to this type of analysis. Mostly the satellite data, I'm really excited to see it and how we can better understand the causes and consequences of erosion along the coastline so we can better understand the uncertain future of the Great Lakes. Thank you. And I think somebody else is going to come up.
Thank you so much, panelists. We're now going to open this to questions both in the room and online. As a reminder, raise your hand as these folks are. If you are online, please put your question into the Q&A box and we'll get to you as well. Please tell us who you are so that we can identify you. We will read your question to the panelists. I'm going to start with this gentleman here.
I'm Eli Kintish with Science Magazine and Newsy Network. Riley, you showed some data just now that showed that the lake level had gone up from the first picture and then it come down, and it was roughly the same. If the water level was roughly the same, why did the coastline look so different from the first shot to the second one?
Yeah, thanks for that, Eli. First I would direct you, we have a coastal geologist who can tell you a lot more about the geomorphology than I can. His name is Robin Mathias. He's presenting several posters here at AGU, so he'll be here. But that's one of the reasons that dynamic, I chose that dynamic thing, that dynamic period of time, was we had a rise and then it came back down. Now, when that happened, that's one of the things we're going to further investigate with the satellite data. That's one of the importances because you get imagery every week, every day. I was just presenting a summary here of what had happened. Even though the coast had come back to the water level had come back to about its same spot, it had risen, very, very high in that period. And there's still a lot of things we're figuring out about coastal erosion, but one of the things we do know is that high water level can contribute to that. So even though it came back down, there was still that period of time where there was high water level, and probably a lot of the erosion might have happened during that time. But that's one of the things we want to find out is when exactly is the erosion happening. There's also a seasonal component. You get storms that contribute to erosion in that time period as well. So I would say is you take a look at that first half where it's rising and you get some happening there. You might not have in that environment as much in the decrease, but you've already had that rise in the water level. And it shows that even though there is variability in there is some uncertainty as to how much the water level is going to change in the next years. There is that rise and fall, which Alexander pointed out is still going to be happening, can still erode the coastline, even if it comes back to the same level in the end.
Just a quick follow-up. The lake water level is measured somewhere far from the coast.
Yeah, so it's Lauren might be able to better answer that than I will, actually.
Yeah, I can answer that. So the data, I think all of the data that we were showing was lake-wide average water levels. So lake-wide average is coming from a network of gauges that are operated by the US, by NOAA, and by Canada, the Canadian Hydrographic Service. So there's a network of gauges throughout the lakes, and so it likely isn't, at the location.
Yeah, I know for Illinois, there's two buoys in particular that measure it. One of them is actually quite close to this site, although it's a little bit north of it, and another one is near Calumet City.
Thank you. Nick Kosar from Aubongon Water Show. I think I should ask you, Riley, about the groundwater levels in the whole area. Have you also monitored the groundwater levels all around the basin during these years or not?
I don't do that, but I do know that in Chicago area, there's pretty much for as long as you can measure since it's been a population center, there's been a very large decrease, and that's something that I would say probably is not a major contributor here, although I would need to talk to somebody who knows more about that. But in the Chicago area, for sure, there's been a great decrease to Chicago pulling out a lot of water from the groundwater. Well, maybe somebody else can speak more to how that contributes, but I don't think that's a major contributor to the lake levels.
So, yeah, I can help with that.
Yeah.
Alexander, you can feel free to chime in, but so there's a couple aspects to groundwater. There's like the direct discharge of groundwater from the coast, right? And then there's groundwater that would be the base flow in the streams, and we're lucky in the Great Lakes, we have a good good fraction of our flow is base flow. So how that's changing over time, I think we would have to look to our partners at USGS to kind of give that kind of like projection and understanding of those changes. But the important part for the water balance perspective that's impacting the water levels, like what's coming out of the coast directly, we think of that as being relatively negligible compared to the rest of the water basin. So it's really, or water balance. So it's really what we would be factoring into the runoff component of the water balance. So it's, we've had periods of high runoff and periods of low runoff throughout that period of record.
Yeah, you had said there were three major components when you kind of gave your summary. I remember.
Yeah. So when Lauren and I did talk about that, the three drivers that we were thinking about were precipitation over the lake, evaporation leaving the lake directly, and runoff from the streams into the lake. And part of runoff is made up of base flow, like Lauren mentioned, which is primarily fed by groundwater. Well, any additional runoff is runoff from precipitation events that we see. In terms of the groundwater that's infiltrating directly into the lake, our sensitivity analyses have shown that that's going to be relatively small in comparison to the magnitude of that precipitation, evaporation, and land runoff in terms of impacts of that groundwater fluctuation that might exist on erosion. I really don't have expertise there.
Going to take a question from online and then we'll come back to the room.
Yes, hi. We have a question from Graham Lawton at New Scientist. Do the recent water rises in the Great Lakes have the same underlying causes as those in the lakes of the East African Rift? Is this a global trend?
I can take a stab at it, though I'll have to add the fairly large caveat that I'm not a climate scientist and certainly not a global climate scientist. So when we think of recent water level changes on the Great Lakes, this might be caused by some deformations of one that we think about as the Arctic polar vortex, along with some coincidence of maybe very high precipitation. I don't see the connection immediately to the African Great Lakes, but these global changes worldwide do underscore the need for the sort of water balance modeling that Lauren and I are talking about, because there is increased uncertainty in those systems. Do you have anything to add, Lauren?
Yeah, no, I don't have familiarity with the African Great Lakes, but I have seen, research pointing to changes in surface water temperature, which could have impacts, especially like for us, if we have changes in surface water temperature, that's going to impact how we see that interplay between the atmospheric temperature and the surface water temperature influence evaporation. So, I think that is like a globally relevant trend is the warming surface water temperatures, but how it plays out in terms of water balance is likely different among lakes. But I'm not familiar with the African Great Lakes.
So I have a question. I'm just considering the importance and the significance. As you guys mentioned, the water level will, vary, but the variation range is like 1 meter to 2 meters, kind of shallow. So will this variation of water level make a huge difference, or can it have some, serious implications?
I can address first that variability piece and then turn to Lauren for some of the implications. while our research didn't focus on the variability, we did see that there's certainly continued variability, at least as large as it had been in the past. And there's been other research around the basin that suggests even an increase in the water level variability. So that the kind of maximum range that we've seen historically is something on the order of 2 meters that might go up in the future. Although, like I said, there's plenty of uncertainty there. And as Lauren mentioned, and I'm sure we'll elaborate on here, even though that magnitude of water level change interannually might be somewhat diminutive compared to really large tidal changes on the coast, the infrastructure around the Great Lakes wasn't necessarily designed for those sorts of fluctuations in mind. So there is some vulnerability there that she can elaborate on.
Yeah, no, I think you got it there. So, yeah.
We're going to take another question online and then we'll come back to the room.
Hey, we have a question from Nancy Averett at Food and Environment Reporting Network. Can any of the panelists talk about how the flooding and erosion, including the loss of wetlands, could impact farm runoff and algal bloom formation in the lakes?
So I think I'll direct that listener to Monica Allen, who's sitting in here. We have work at NOAA that looks into impacts of changes on runoff and water quality and potential influences on lake water quality. So Monica Allen is sitting in this room. Oh, not directing it to her, but to help answer. It's an online question. Yeah.
MONICA.Allen, ALLEN at NOAA.gov, and I will help you if you just email me your question again. I'll help you get some of our experts from NOAA's Great Lakes Environmental Research Lab. Thanks, Lauren.
We'll drop that in the chat as well. We have another one in the room.
Hi, I'm Morgan McFall Johnson from Insider. I guess I also had a question about infrastructure. I think that Lakeshore Drive was a really good example of this, but I'm curious to hear more specifically about the risks to infrastructure from this increased variability and erosion. Are there particular types of infrastructure that are most vulnerable to this, or particular locations or sites? And then I'm curious, what does adaptation to higher variability look like?
I'll take a stab. I think Eve might be able to talk more about the flooding impacts, but the type of damage that you're going to see is really going to depend on the type of shoreline that you have. So if you have, long sloping shoreline, you'd be more interested in the kind of the flooding impacts. Whereas a lot of the coasts, especially on Lake Michigan, one of the images I showed was, house falling into the water. And so there are serious impacts, of coastal bluff erosion too, that would be important for those types of shorelines. So it really depends on the shoreline. I think you can talk more to the flooding impacts potentially.
Yeah, thanks for the question. And as we just presented, our model are capable to simulate the flooding areas along the coast of the Great Lakes. So the coast types, there are beach, and also some communities are directly faced on flooding. So using the information, simulated information, so where could flood it, we could inform the local agencies or local governments to have some specific infrastructure to prevent the flooding risks. So and also there are currently some high risks areas. So we are currently working on, so we could have some more results later on.
And I'll just say that's what I was trying to communicate with that one slide where you saw the different types of coasts. The picture that I showed you was from what's probably the longest quote unquote natural or unprotected stretch of beach in Illinois. And so we see some of the more natural processes there, but if you go down to Chicago, you will have a lot of protective structures that are there to increase resilience for the infrastructure that's in that area. That's not to say they're not vulnerable. But there might be other things that they're susceptible to, like what E pointed out. You might have flooding or other things like that. So I'll just reiterate what they said. It kind of depends on the exact location and what's going on at that spot.
We have a couple of questions online.
Yes, we have a question from Tom Henry at the Blade, which is based in Cleveland, I believe. How are fluctuating water levels in Lake Erie affecting Great Lakes shipping and the need for dredging, which is greatest in the Toledo area because of shallowness there? How much uncertainty is there now, and how does this affect the region's economy? And apologies, I think it's in Toledo.
I can take that one. So, yeah, the Great Lakes are really an important resource for navigation. And so the question was around how much the lake level changes will impact navigation. And, while I can't say I don't know the projected changes in navigation economic impacts, I do, they are folks, primary, stakeholders who would be interested in the forecasts and longer term projections of lake levels to help them plan for how much they can load. And I think there was also a mention of dredging. So folks like Army Corps of Engineers would have interest in this for that purpose, for maintaining navigation channels and harbors.
I guess to get kind of more directly to what impacts may be with variability and if we're thinking about dredging for navigation and things, then that navigation becomes more challenging in periods of low water levels. If variability is maintained into the future, we anticipate continued interannual periods of low water levels as well as high ones. So there is going to be some infrastructure adjustments that might be needed during those time periods. And if that variability in water level even decreases so that more extreme values on both the low and high end are more frequent or have longer durations, then that need for adjustments to allow navigation could be even larger.
I'll just add one more thing. This doesn't address Lake Erie, but to kind of answer the earlier question too, with respect to dredging, that's one of the reasons we want to understand how sediment is moving along the coast. So even though Chicago is an urbanized area, and you might not think of erosion as an issue for Chicago, if you have that littoral movement or that sand movement down the coast, it might end up in a navigation channel. And then you need to worry about dredging and things like that. So understanding the whole complex thing, water levels, erosion, what's going on with the infrastructure at a particular site is much more than what's going on at that site. It's a larger system.
We have one more question also from Tom Henry at the Toledo Blade. The value of Lake Erie beaches has recently been quantified by an Ohio State University researcher as $148 million as of 2019 for 28 beaches in Lake Erie. Can you explain how water levels and erosion will impact the beaches and thus their value to society?
I was going to look to Riley maybe to talk about beach erosion. I don't know if that's relevant to your.
Yeah, I don't know much about the value. I
Yeah,
can't speak to that.
So I don't think we don't have an economist here, so I'm not sure. But I think like what you showed was changes to that beach, and so I think looking ahead at what kind of changes we might see might be a way to do that with the help of someone who's more versed in economics.
I agree. And I cannot speak to the economic value, but since we're at a scientific conference, I can speak to the scientific value, which is that a lot of the lakeshore that I specifically showed with that optical imagery has records of the Lake Michigan geologic past for thousands of years. And so that's not necessarily economic value, but geologically, it will be important to understand what went on in the past at those locations, the shorelines, before we lose it, because we're not going to be able to get those geologic records back once they're lost. That's not an economic value, I understand, but there are lots of types of things that we can lose in addition to the economy when we have a variable coastline.
Yeah, a very first order analysis of water levels in beaches is that when water levels are high, your beaches are going to be smaller because the water level is just further up the coast. And that might even be coupled with increased erosion, like Riley mentioned, although there's multiple factors going on there. And then when water levels are low, you anticipate those beaches might be a little bit larger just because the water has receded away. And how those different things translate into economic value, I think we'd have to look for someone else on, but that's the type of thing that we'd be thinking about.
One last question from online or in the room? Did we have last call? Last call?
Hi, I'm Josh Blumenfeld. I'm with NASA. Lauren, you mentioned that the 100-year record showed no clear trend of decreasing water levels. I'm just wondering, what did the data show in terms of storms? The number and intensity of storms, are these increasing? Do these seem to be relatively stable as well?
Yeah, I'm not as well versed in the storms, but we do know that there's been increase in like intensive precipitation events, for example. So that could be associated with that kind of storm event. But like in terms of, you know, how wind events are changing, that I don't have.
I also don't have an answer to that, but to give context, the wind events are important because that's often what's shaping the erosion in my research. And that's one of the points to better understand with this finer resolution data is because the trends that we're showing are long-term trends, but to understand what's happening with erosion, you almost need to understand at a very fine temporal scale. You need to be able to see what's happening in the winter, for example, with ice, which is somewhat unique to the Great Lakes. And you also need to understand what's happening from before a storm and after a storm. That can be you can have a very big difference in just a week or so, just based on one large storm. So I don't know that I have an answer for that, but I do want to underscore the importance of understanding how those storms are affecting the coastline, because those are often the events where we get large changes.
Going to take a final question from online.
Our last question comes from Danielle Kading with Wisconsin Public Radio. Are there differences within the lakes themselves on swings between low and high levels? Do we see more variability in any one lake? And if so, why? And she is particularly interested in Lake Superior and the Michigan Huron system.
Okay, so that's a good question about the differences in variability among lakes. I was just showing Michigan Huron here to keep the slide simple. So the lakes do have, you know, they'll show different responses at different times just because of the variability of the climate within the region. So for example, Lake Superior actually had a little bit of a more rise than normal, whereas the rest of the lakes recently didn't see that that wetness. We've been in more of a drier period. So there can be different climate impacts depending on where you are in the basin. You know, it could be a north-south gradient or east-west gradient of those changes. And so the variability, the total variability is different between Lake Superior has a bit less variability in terms of like difference between maximum and minimum over the period of record than the other lakes. And my take on that is that we have a less kind of, if you think of the added variability in inflows and outflows that you would add to variability in your precipitation runoff and evaporation on the other lakes. Lake Superior's inflow is really just coming from a very small diversion from the Hudson River Basin. So that's the Long Lock and Agoki diversion, which is really quite small compared to the rest of the water balance. So any variability in that diversion is really not going to have a big impact on the variability of the lake. So that's to me kind of the basis of that difference in vulnerability. But it's a good observation that the rest of the lakes have a wider range of levels.
Yeah, even pulling in the forecasting piece of that a little bit, we do see a bit less variability on Lake Superior. And I think I'd have the same assessment as Lauren, that a lot of the cause of that is the other Great Lakes have a really large other factor driving their water level is inflow and outflow from the lakes surrounding them. So we see the greatest variability on Lakes Michigan and Huron because they have a lot of inflow coming from Lake Superior, and they're losing a lot of outflow downstream through Lake St. Clair to Lake Erie. So both of these pieces are two other really kind of large magnitude factors in the water balance that can just add increased uncertainty to the system, and even projections into the future take that into account and project that the water levels throughout the system are going to be the most variable on Lake Michigan Huron.
Great. Thank you so much, panelists. Thank you all for coming. That's going to conclude this event today. This event has been recorded and will be available on AGU's YouTube channel later this afternoon in a playlist called Fall Meeting Press. We will post that link and the slides from this session to the AGU Press Information Exchange, which you can find on the online press center. My colleague will pop that into the chat for those online. And if you have a question in the room, please come talk to me. You can, as always, reach us at news@agu.org. Thank you.